Hello everyone, thank you for joining me on the video to finish up the more difficult trig equations. This is a problem that I would like for you to try on your own. But first, let me remind you of a few things. We're dealing with tangent, so I wrote the basic tangent values here. I also wrote down what sign tangent is in each quadrant. I would like you to isolate the trig function, think about that it's rotating twice, and see if you can get this question right on your own. I'll be back with my work in a bit, so please pause now. Okay, so here were my final answers. If you got it right, that's fantastic. Great job. If you didn't, here's what I did end up doing. I divided both sides by 2. I can't divide by this 2 because this one represents a rotation and is attached to the angle. So after I divided by 2, I got tangent of 2x equals 1. So I asked myself, if I wasn't rotating twice, just once, where does the tangent value equal 1? Well, that's true at pi over 4 and 5 pi over 4. So instead of x equals these two answers, I said that 2x would have to equal pi over 4 and 5 pi over 4. But because it's rotating twice, I really added 2 pi, or with a common denominator, 8 pi over 4 to both of these one rotation answers. When I did that, I got 9 pi over 4 and 13 pi over 4. But I checked 13 divided by 4, and I got that to be 3.25 pi, which was not between 0 and 2 pi. So I multiplied by the reciprocal or divided everything by 2, and that is how I got all of my final answers here. And don't worry, we'll be practicing this a lot in class as well. I just want to give you a chance to try it first. So on to our last example. Again, we want to solve from 0 to 2 pi. This one looks complicated because I have a squared term and a fourth term. I do want you to notice that both of your angles are rotating twice. So eventually we have to deal with a lot of answers. So it's equal to 0. That's a good thing. Whenever you're not sure what to do and it's equal to 0, think about the idea of factoring. And usually a good starting point is a greatest common factor if it applies. So if we looked at this, it's the same function, cosine of 2x. This one's squared and this one's to the fourth, which means that a greatest common factor is 2 of them. So if I take that out of both terms, if I take cosine squared out of cosine squared, I'm left with 1. If I take cosine squared out of cosine to the fourth, I'm left with cosine squared of 2x equals 0. So what I could do is I could set this equal to 0 and I could set this equal to 0. You also could, if you're interested, use a trig identity. Even though the angle is rotating twice, the idea of sine squared theta plus cosine squared theta equals 1 is still true. So I could replace this with sine squared of 2x instead, and then times cosine squared of 2x, and I could set both of those equal to 0 if I'd like to. So I know that cosine squared of 2x equals 0, and sine squared of 2x equals 0. You could have also just set this equal to 0 if you wanted to, but I thought I'd use an identity in the video for review. Now if I want to solve these separately, to get the trig function alone, I'm going to take the square root, because I need to get rid of that squared. So I have cosine of 2x technically equals plus or minus 0, but that's rather ridiculous. So cosine of 2x just equals 0. So let's think about that. Where does my x value equal 0 on my unit circle? Here and here. So in another color, remember that you're really saying that cosine of x, if I was rotating once, the answers would be at pi over 2 and 3 pi over 2. But I'm rotating twice. So I know that 2x equals, these is my first rotation at least, so pi over 2 and 3 pi over 2. But if I am adding 2 pi, I'm really adding 4 pi over 2. So if I add 4 pi over 2 to this, I get 5 pi over 2. If I add 4 pi over 2 to this value, I get 7 pi over 2. And just like the last couple examples, I need to multiply by the reciprocal. And if I do that, I get values of pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So that is 4 answers just for the first piece. So we have definitely more to go here. If I look at the second example, I want to say, where does sine squared 2x equal 0? Well, just like the last problem, I'm going to take the square root. So I'd get sine of 2x equals technically plus or minus 0, or just 0. The places that sine with a rotation of 1 equals 0 is going to be at 0 and pi. However, now I'm dealing with 2x. So 2x, or 2 rotations, would be at 0, pi, and then 2 more blanks. The good news is we don't need a common denominator this time because these are both over 1 technically. So if I add 2 pi to 0, I get 2 pi. If I add 2 pi to pi, I get 3 pi. So now I can multiply by the reciprocal, because definitely 3 pi is not between 0 and 2 pi. And if I do that, I get that my angles are 0, pi over 2, 2 pi over 2 technically, which is just pi, I'll reduce that in a minute, and 3 pi over 2. So more simplified, it would be 0, pi over 2, just plain pi, because we had 2 pi over 2, and then 3 pi over 2. So this problem had 8 possible answers, or 8 possible solutions. So this ends this video. Yes, at first there's a lot to think about on these problems. There's identities you need to think about, the unit circle, but the more practice you get and the more practice you're willing to do on your own, the better you will get at this. It's like anything else. The more you practice it, the better you're going to be. So thank you for joining me, and we'll practice more in class.